this example, it says Bryce and his sister Julia have a savings account for college. In April, Bryce's account had a balance of $2,000, and he plans to deposit an additional $50 per month. At the same time, Julia's account had a balance of $1,600, and she plans to deposit $100 per month. Predict when Bryce and Julia, sorry, I forgot that in there, Bryce and Julia will have the same amount in their college fund. Well, when we do this problem, we have to actually set up our equations. Now remember, if we're talking about Bryce, the amount he has in his account is $2,000, and he's adding an additional $50 per month. Remember, we talked about writing equations before. If I'm going to say his balance, Y, is going to equal what he has in there, $2,000, plus an additional $50 per month. Remember, when you see that word per, that tells us your slope. That tells us how much it's changing every month. So we're going to write it as 50x. If we're talking about Julia, her account is going to have a balance of $1,600, which she currently has right now in April, plus $100 per month. So again, that's our rate of change and that's our slope. Now, normally if we go to graph these things, it's already in slope-intercept form. I caution you though, when using numbers like this, they're very big numbers. So if I were going to draw a graph and I'd plot, I don't know, 2,000 right here, and I'd say, okay, I'm going up 50 over 1, I can't count out 50. That's too high. Now you could, if you recognize as each of these going by 50, then you could do it, but then you have to make sure that you're going over by 1. It's not impossible to do, but my advice to you is to maybe make an input-output table for these. So, for example, if I were going to work with both of these equations here, okay, let's look at our first one here. I would make an input-to-output table for that equation. I would make an input-output table for this equation. So I will have blue represent, oops, let's have blue represent Bryce. Okay, so I'm just going to make an input-output table and have an x and y value. I'm going to put 0 in to start. If I put a 0 in here for x, 50 times 0 is 0, so I get 2,000 plus 0, which ends up being just 2,000. And then maybe I'll put in like 2 months. What happens after 2 months? So I'm going to plug a 2 in here for x. 50 times 2 is 100. And so that would give me 2,000 plus 100, which is 2,100. Oops. Oh, let's see what happens after, I don't know, 6 months. Okay. If I plug a 6 in here, I get 50 times 6, which is 300. 300 plus 2,000 is going to be 2,300. So let's plot these points. These are the x-axis here is going to represent our months, and this is going to represent the balance of the account. Okay. At 0, 2,000. Okay, so we got to identify our scale here. Months is pretty self-explanatory, but I might skip one line just to make the table look a little bit neater. So like this is 1 month, 2 months, 3 months, 4, 5, 6, 7, 8, 9, 10, hopefully this is enough room, 11, and 12. Okay, now maybe going up the side here, we're starting with 2,000 and 1,600, so I am maybe going to do by 400 by 200 actually, but I'm going to just write down the red lines here. 400, and again, you can choose a different scale, it's okay. I'll say this is 800, 1,200, let's see, 14, 1,600, and this will be 2,000 here. Okay, 24, I'm going to start skipping some here, 28,000, 30, oops, this is going to be 3,600. Okay. Okay, so again, plotting our points, 0, 2,000 for Bryce. And again, if we just did slope, we got to be careful what our grid lines represent. But if I plot the point 2, 2,100, 2, 2,100, remember I went by 200s actually, so that'd be right here. And end up with another odd one, 6, 2,300. 6, 2,300. So here's 22, 23. Okay, and we're going to draw a line through it. We'll draw it going out like that. Okay, and now let's make an input-output table for Julia. Again, I picked input-output tables just because of the big numbers we're dealing with. If I plug a 0 in here, get 100 times 0, which is 0 plus 1,600, which is going to be 1,600. Oh, I'll use a 2 again. If I plug a 2 in here, 100 times 2 is 200 plus 1,600. It's going to be 1,800. Oh, and let's do, well, we can do the same. Let's do 6. If I plug a 6 in here, that's 600 plus 1,600 is going to be 2,200. Oops. You know what, and just for the sake of things, I'm going to make it a little bit bigger here. I'm going to say I'm going to pick 10 months. If I put a 10 in here, that's 1,000. 1,000 plus 1,600 is 2,600. Okay, so let's plot these points. 0, 1,600. That's kind of why I went by 4s, because I knew that would be an easy number to find there. Oops. 2, 1,800. 6, 2,200. Right here, so we're getting awfully close. And 10, 2,600. So over here at month 10, here is 2,000, 22 or 2,400, 26 would be right here. Okay. So now we're drawing our red line through them. Looks to me like our lines are going to intersect here. Oh, let me fix my lines a little bit. Again, make sure they're going through the corners of the grid lines. I make my point so big it's hard to tell. Okay, it looks like they're going to intersect right here at the point 8, and let's see where we're at, 2,400. So after 8 months, they're going to have $2,400 in there. Okay, so in April, if we count 8 months out, May, June, July, August, September, October, November, December. Predict when? Well, I'm going to predict that in December, they will have the same amount in there, okay, or after 8 months. You want to know if you're right? Plug it in here. If I plug an 8 in for X here, 50 times 8 would be 400. 400 plus 2,000 is 2,400. And if I plugged an 8 in here, just a different color so you can see, 100 times 8 is 800 plus 1,600 is 2,400. So I know that works. So after 8 months in December, they will both have the same amount of money in their account. And we can tell that from our graph.